Welcome back. We're still on the graphs of motion under the vertical projectile motion. Ball A is projected vertically upwards at a velocity of 16 meters per second from the ground. Ignore the effects of resistance. Use the ground as your zero reference. Calculate the time taken by ball A to return to the ground. Right, let's have a diagram here. Let's say this is the position time graph. Right, it will be our y in meters and then our time in seconds. Right, zero reference is the ground, and then the ball moves up. After a few seconds, it's going to be up there at the maximum point. Then after a few seconds, it will be back on the ground. So it will be like this. Right. Then the initial velocity. Okay, this is the initial velocity here. We have the initial velocity, which is 16 meters per second. We know that. And then the velocity, your final velocity, is going to be negative. If you're taking upwards as positive, it's going to be negative 16 meters per second. Here at the maximum height of the ball is going to be 0 meters per second. Right. So now there are two ways of doing this. We can use this half, the time symmetry. Also, we can use this one. So I'll show you first with initial velocity of 16 meters per second and final velocity of negative 16 meters per second. Then the other one I'll show you with what? The 16 meters per second as the initial velocity, and then the final velocity is the one at the maximum height. If we take upwards as positive, the initial velocity is going to be 16 meters per second, and then acceleration, if we take upwards as positive, is going to be negative 9.8 meters per square seconds. And then final velocity, we see, let's use this one. So final velocity is equal to negative 16 meters per second. And then what are we looking for? We're looking for time. So we can use our formula. Final velocity is equal to initial velocity plus acceleration times time. Right. Let's substitute what we have. Negative 16 is equal to 16 plus negative 9.8 times time. Right, this is like negative 32 is equal to negative 9.8 times time. Then divide by 9.8 on both sides of the equation. We get that time is equal to 3.27 seconds. Now, if we use 0 meters per second as the final velocity, you can say we have our initial velocity, which is 16 meters per second. We're still taking upwards as positive, so A is equal to negative 9.8 meters per square seconds. And then our final velocity is 0 meters per second. We're still looking for time. Right? We use our final velocity is equal to initial velocity plus acceleration times time. 0 is equal to 16 plus A negative 9.8 times time. Okay, then negative 16 is equal to negative 9.8 delta t. I divide by 9.8 on both sides of the equation. Okay, that delta t is equal to 1.6326 seconds. Right, which is this time from there up to there. That is 1.6326. Right, and then now we want the time from the ground and back to the ground. It means we have to say 1.6326 times 2. Therefore, the time taken will be 1.6326 times 2. Then delta t is equal to 3.27 seconds. We're getting the same answer. But let's say you took downwards as positive. Remember, you choose one. You don't need to do both methods. I'm just showing you so that we have more than one options. If we take downwards as positive, so it means our graph is going to be like this. Taking downwards as positive, that's our position time graph. When the ball is going up, displacement is negative. If you take downwards as positive, when the ball is moving up, then displacement what? Displacement is negative. So the graph is like this. This is a position time graph. It will be like this. So time, seconds there, then displacement m. We're taking downwards as positive and the ball is going up. So the initial velocity is negative 16 meters per second. Okay. Remember, this is the displacement time graph. The graph does not represent what? Does not represent velocity. I'm just writing the velocities at t is equal to 0 there. And then the velocity at the turning point here is 0 meters per second, right? And then the velocity there, the ball is going down. We're taking down as is positive and the ball is going down. So the velocity is going to be positive 16 meters per second. Okay, please take note of that, right? But this one, the graph, please take note, the graph is about what? Is for displacement, not the velocity. We're going to draw the velocity time graph in our next question. We have our initial velocity, which is negative 16 meters per second. Then acceleration, if you take down as positive, acceleration is 9.8 meters per square seconds. Final velocity is going to be 16 meters per second. We're looking for time. Okay, same calculation. Final velocity equal to initial velocity plus acceleration times time. Right. 16 is equal to negative 16 and then plus 9.8 times time. Then 32 is equal to 9.8 times time. Divide by 9.8 on both sides, we have 3.27 seconds, which is equal to delta t. Okay. Right, if we use this as our final velocity and this is our initial velocity, what do we get? Right, we have our final velocity, which is equal to what? 0. But the initial velocity is what? Initial velocity is negative 16 meters per second. Meters per second. Alright, and then acceleration is going downwards is positive. Downwards is positive. Acceleration is 9.8 meters per square second. Right, and then we're looking for time. Vf is equal to Vi plus A times time. Acceleration times time. And then 0 is equal to negative 16 plus 9.8 delta t. 16 is equal to 9.8 delta t divided by 9.8 on both sides of the equation. We get 1.6326 is our time. Now to get the time from there up to there, we need to multiply by 2. This is just for this part. So we multiply this by 2. What do we get? We get that our time is equal to 3.27 seconds. Let's do the last part. Ball A is projected vertically upwards at a velocity of 16 meters per second from the ground. Ignore the effects of air resistance. Use the ground as your zero reference. Sketch a velocity time graph. For ball A, show the following on your graph. The initial velocity of ball A, time taken to reach the highest point, and then time taken to return to the ground. Please take note of this. Time taken to reach the highest point is what? It was 1.63. And then time taken to reach the ground again was 3.27. And then the initial velocity we have, and then the final velocity also we have. Okay, when it reaches the ground, the magnitudes of the velocities will be the same. The only difference will be the signs. Please take note. So now, we have to use one. You don't need to do both. But I usually show you when we take upwards as positive and also take downwards as positive. Let's start by taking upwards as positive. If we take upwards as positive, please take note, the gradient of the velocity time graph gives you acceleration. The gradient of the velocity time graph gives you acceleration. So when we take upwards as positive, is acceleration negative or positive? If we take upwards as positive, acceleration is negative. Since acceleration is the gradient of the velocity time graph, and if we take upwards as positive is negative, then the graph of the velocity time graph must be decreasing. Remember, if the gradient is negative, the graph is decreasing. Okay, so it means our graph should be decreasing. If we take downwards as positive, our acceleration is positive. Since our acceleration is the gradient of the velocity time graph, it means the velocity time graph must be increasing if you take downwards as positive. Okay, let me just explain further. Right now, if we take upwards as positive, we say that the initial velocity is 16 meters per second, positive 16 meters per second, okay, which is there. And then the graph must be decreasing here, because if you take upwards as positive, acceleration is negative, and then acceleration is the gradient of the velocity time graph. So the graph must be decreasing. It's going down like this. Now this is at the maximum point where the velocity is 0. This is velocity. And then the time to reach the maximum height is what? 1,63. When it reaches the ground again, the velocity will be at negative 16 meters per second. Okay, same as this one. The magnitude will be the same, but different signs. And then you can see our graph is decreasing. And then you can indicate your time there, which is 3,27 seconds. If we take downwards as positive, remember these are just the same graphs. We see only that this side we're taking upwards as positive, and then here we're taking downwards as positive. But if you take downwards as positive, the initial velocity is going to be negative because the ball is going up. So the initial velocity is going to be negative, right? And then the graph should be increasing because when we take downwards as positive, the acceleration is positive. And then acceleration is the gradient of the velocity time graph. So if it's positive, the graph should be increasing. So we have our initial velocity there, then it goes up. This is at the maximum point when velocity is 0, which is 1,63 seconds. And then we have 16 meters per second when it reaches the ground. Okay, because it will be going down. By the time it reaches the ground, it's going down. And then if you take downwards as positive, the velocity also will be positive. Then this is our graph increasing like that. And then this is the time, 3,27 seconds. Okay, so it's either you have this diagram or this diagram.